How are you, my friends? This is a continuation of the series Basic Math Terms, and this video is part 28 that will cover some terms in statistics. Also, part 29 will continue in statistics. Now, if you go down here, Calculus 1 terms videos will be starting from part 30. You can check the algebra terms, parts 1 to 18, if you like. It's already there. And the pre-calculus terms, parts 19 to 27. Now, here we have 14 words that we need to explain in part 28 of statistics. What is statistics? This is number one. Population, sample, data set, discrete, continuous, mean, summation notation, average, arithmetic mean. You can ask why the same color here, 7, 9, and 10. I will tell you why. Number 11 is median, mode, range, and Greek alphabet. What is statistics? It is a branch of mathematics where we take a collection of data, usually numerical data, numbers, and we make the analysis to draw conclusions. So in statistics, set of data is described and interpreted in a meaningful way, and it can be applied to scientific, industrial, or social problems. Now, there are many benefits of studying statistics. I mentioned here three. The most important is to effectively conduct research for future improvement. Population and sample. A population is the entire group, individuals or things that you want to draw conclusions about. So if you are studying a certain number of people or things, all of them, we call this population. Now, in research, population does not always refer to people. It can mean objects, events, organisms, or anything. A sample is a set of individuals or objects that you will collect data from. From the word sample, it's very clear that the size of the sample is always less than the total size of the population. So we say in mathematics, a sample is a subset of a population, and here is the diagram. Population is the entire group that you need to study, and sample is part of it. The sample elements, we call them sample points. Now here you see 4 diagrams just to understand the difference between population and sample. I have explained the first one. Second one, you can have a population of people, and there is a sample. Third one here, you can see sample of an infected area. You can just take part of that. Or this sampling technique, you have many things there, events or people, or trees or birds, and then you can take part of them to study and analyze. Dataset is a collection of data, often numeric. So there are numbers that are collected through observation. These data can be discrete or continuous. I put here a little diagram. This is the graph of a discrete. It's finite, countable, non-negative integer, like 1, 2, 3, 4, 5, 6, etc. These are integer numbers. So integers are not fractions. Integer numbers are not fractions like here. Fractions and decimal numbers like 2.56, 1.89, fractions 2/3, whatever. These are continuous data. So they are continuous by time, like height, weight, time, temperature, age. Discrete is finite, countable, like number of students. We say number of students. 17 students. We cannot say 3/2 or 1.5. That's not correct. Number of computers in a school, it's a discrete. Shoe size is a discrete. It's a number, positive integer. Also here I put 4 examples to show you the difference between discrete and continuous data. The first one we have seen in the previous slide. This one you can draw it like this. The dots are the discrete, and here we have a discrete, points separate, continuous, it's all continuous. And also this is another example in the graph. Now the mean, arithmetic mean, and average. Let's say, what is the mean? Mean is a number expressing the central tendency in a set of data. So the mean can be thought of as the middle point between extremes. Most people, they say average. So this is important note when we say find the mean or arithmetic mean or the average, they mean the same. That's why I put them in the first slide, the same color. How to find the mean? It's so easy. Let n be the number of data points. So the mean will be the sum of the numbers divided by, see, this is divided by the count, how many of these numbers. So the mean is simply the sum of the terms, you add them, divided by the number of terms, how many terms are there. I can put that in mathematical terms here. X dash, if a sample is used. So that's a sample, part of the population. We say summation, this is, we call it summation of xi. I goes from 1 to n, all divided by n. That's the same formula, guys, here. This is mu. Mu from the Greek alphabet for complete population. If you are using the complete population, then you write mu. That's the same formula. You take the summation of xi, I goes from 1 to n, all divided by n. The formula is the same, only the mean, if you use the population, the whole population, use mu, and if you use the sample, use x dash or x bar. Okay, let's see example number 1 on the average. In a math quiz, out of 20, students' grades are 11, 11, 19, 20, 16, 18, 11, 14, 19, 16, 8, and 15. Find the mean of this data set. That's a complete population. This is the whole class, and you are using all the students, so you can say mu. So the mean or the average, it will be the sum now, in this example, the sum of the grades divided by the number of students. So just sum them, summation, xi. So this is like, we can call this x1, x2, x3, x4, x5, x6, etc. You add all these grades divided by 12. Why 12? N is the number of students. So this is 2, 4, 6, 8, 10, and 12. So there are 12 students. So 178 divided by 12, that will be 14, approximately 14.83. So this is mu, and this is the mean, and this is the average or arithmetic mean. Let's see another example on the average. For a large population of newborn babies in a certain city, we take a small sample of 9 individuals, considering their lengths are given below. So 45 centimeters, this is the length of a baby, 49, 50, 53, 56, 60, 56, 55, and 47 centimeters. Find the mean of this data set. That's a sample, so we can use x dash. But the formula is the same. It will be the sum of the lengths divided by the number of babies. So x dash or x bar will be 45 plus 49 plus 50 plus 53 plus 56 plus 60 plus 56 plus 55 plus 47, all divided by 9. Why 9? The number of newborn babies. So this is 471 divided by 9. It will be 52.3 centimeters. This is the mean. Median, let's define it. In statistics and probability theory, the median is the value separating the higher half from the lower half of a population or a sample. So how to find the median? Put all the numbers in ascending order from smaller to larger. So we take here two examples. The newborn babies, we have 45, 49, as we mentioned before. Let's rearrange it. It will be 45, 47, 49, 50, 53, 55, 56, 56, and 60. So how many people are there in the babies? We have 9. 9 is an odd number. If data set is an odd number, then the median is the middle number in the given sequence. So here we have the first 4 and the last 4, you see? Because this is an odd number. So 53 is in the middle, so we call it the median, 53. That's an odd. Now in the next example about the math quiz, we have 12 students. That's an even number. If the data set is an even number, like 12, like 8, like 4, like 16, like 20, like 60, then the median is the average of the two middle numbers. So here, if I take 1, 2, 3, 4, 5, see the first 5 and the last 5, 1, 2, 3, 4, 5. Then in the middle, I have 2 here because the total number is 12. That's an even. So I take these numbers, 15 and 16, then I find the average of these only two numbers, 15 plus 16 divided by 2. So the median now is 15.5. Now to define the mode, it is a statistical term that refers to the most frequently occurring value in a data set. Sometimes there is no repetition in any of the values, so we say no mode if there is no value appearing more than any other. And also, in some data sets, several modes might be there. We will see on the next slide 3 examples. Here we look at this example, newborn babies. We have the number 56 centimeters here is repeated 2 times, so that's the most frequently occurring. So the mode here is 56. Now in the math quiz, we see there are 3 grades, the most frequently occurring, 11, 11, and 11. So the mode is 11. Even though we have 19 and 19 repeated, and also 16 and 16. But the mode is the most frequently occurring. Now here I have prepared 3 examples about the mode. If 2 modes are there, we call it bimodal distribution. So here we have 4, 12, 6, 5, 5, 7, 6, 8, 5. So we see the number 5 is the most appearing or occurring. So the mode is 5. Here in the set 2, we have 1, 23, 3, 7, 3, 7, 2, 6, 3, 5, 7. So there are 2 modes because 7 is repeated 3 times and 3 is repeated 3 times. So we have mode 1 is 3, mode 2 is 7. In the last set here, we have 16, 3, 1, 11, 7, 6, 9, and 5. And what is the mode? None. There is no mode in the last set. Now the range, by definition, it is the spread of the data from the lowest to the highest value in the distribution. How to find the range? So easy. Put all the numbers in ascending order, if you like, and then find the difference between the largest and smallest. The largest, we can call it highest or maximum. The smallest, we call it lowest or the minimum. So to find the range, the easy formula Range equals max minus min, maximum minus minimum, or the largest minus the smallest. Now, if we go to the newborn baby's example, the maximum was 60 and the minimum was 45. So the range is 60 minus 45 is 15. That means there are 15 steps where the data are spread in this example. In the math quiz, the highest grade was 20 and the lowest was 8. So the range will be 20 minus 8 is 12. Let's look at this practice question, please. You can check your understanding and your knowledge. If the annual salaries of 8 people in a small company are given below, so this is the salary per year, $42,000, $50,000, $43,000, $42,000, $54,000, $49,000, $33,000, and $38,000. Find the following. Find the mean, the median, the mode, and the range. Please, you can try it yourself. Check the other examples. And on the next slide, I put only the answers. So you can check the mean, median, mode, and the range. Okay, put all the salaries in ascending order like this. Then you find the mean is this one, the median is this, mode is this, and the range is this. This is the Greek alphabet in case you need it for any course, math or physics or others. This is alpha. See, I put colors here where we use the most in the math courses. We use alpha, beta, gamma, delta. See, the delta here we use in quadratic formula where we have the solution of a quadratic equation, x equals minus b plus or minus square root of delta divided by 2a. Some books, they write capital D, and some books, they write delta. Delta means b squared minus 4ac. So this is the delta here, capital. And also theta, we have here sine theta, cosine of theta. This is the mu, where we have the mean. This is the mu here. And also the summation, we have seen in this video. The sigma, we will see it also in part number 29. This is also omega, and this is angle phi. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Please wait for the video on statistics part 29 coming after this. I hope I can see you in another video with another topic. Thank you guys for listening.